Hi, today we're going to talk about factoring quadratics. Really, what that means is just taking the standard form and converting it into the factored form. In the factored form, we can actually determine what the x-intercepts are. Sometimes it's called solving for the zeros because if we let y equal 0, we can solve for x. These are the three different steps we're going to use for basic factoring today. We'll make another video on more advanced factoring shortly and post that as well. So let's start off with the very first problem. Y equals x squared plus 5x plus 6. All right, so here we have our standard form. It's in the A, B, and C form of a quadratic. And this is good because we can tell what our A, B, and C is in case we need to use the quadratic formula. The C value also allows us to know what the y-intercept would be of our parabola. But let's say, for example, we want to find out what the x-intercepts are without taking the time to actually graph it. By doing that, we're actually factor this out. So first we're going to look and see if we have a greatest common factor. That means, can we factor anything out of all three terms? Is there anything all three terms are divisible by? In this first example, no, there is no greatest common factor, so we can skip over that. Then we're going to go with y equals, and we're going to draw in our parentheses. Really, if you have FOILed before, we're doing the reverse of foiling. We're kind of taking the trinomial that we created by foiling, we're going to break it apart and put it back in the form of two binomials. All right, so in foiling, we always multiply the first two terms together first, and we get x squared. So we're going to go ahead and put an x in front of both. Because x times x is x squared. Step number 3. We need to find two numbers that when we multiply these two numbers together, we get the c value, which would be the 6 at the end. Remember, that's the c value, right? And then we're going to take those same two numbers, we're going to either add them or subtract them, and we're going to get the b value. Remember, this is your b value when it comes to a standard form. So you got a C and a B. All right. So what two numbers when multiplied together give me 6 that I can kind of combine to give me 5? Well, if I was to create a little factor table here, I could do 1 and 6. 1 times 6 is 6. And I could also do 2 times 3. That's also 6. Now you might think, well, let's try out 6 and 1. So if I plug in a 6 and I plug in a 1, and I want to combine them to get 5. The only way I can do that is if I make the 6 a positive and I make the 1 a negative. Because 6 minus 1 is 5. However, if I use that, positive 6 times a negative 1 is a negative 6. So that doesn't work. So 6 and 1 won't work. So let's try 2 and 3. Let's put in 2, put in 3. Now if I want to add these together, that adds up to 5. So plus 2, plus 3, that equals 5, and a positive times a positive is a positive. So this right here would be the factored form of our quadratic. All right, let's do another one. We're gonna follow the same steps as we go through here. All right, the next one. Let's do y equals x squared minus 7x plus 12. All right, first step. See if there's a greatest common factor. There's not. There will be in the next couple. So. All right, so we're going to put in our parentheses. We got an x squared up front, so I can start off with a couple of x's real quick, just to get us going. All right, two numbers that multiply together to give me 12, and when I add those together, they give me negative 7. So if you can't think about it in your head, once again, we can create a little factor tree and list out all the different factors of 12. 1 times 12, 2 times 6, 3 times 4. Those are all the combinations that we can use to get 12. All right, but to get 7. Okay, well, I can't get a 7 from 1 and 12. There's no way I can combine 1 and 12 to get 7. 2 and 6, the difference between them is 4. If I add them together, I get 8. Can't use them. So I'm going to use 4 and 3. I'll put a 3 in. I'll put a 4 in. It doesn't matter which side I put them in. I could have the 4 over here, the 3 back here. It really doesn't matter. All right, so once we have that in there, now we got to figure out what signs go in here. Well, it's a positive 12. So they either need to be both positive or plus signs, or they need to be both negative signs. If we look out here, we have a negative 7. So there's only one way to get negative 7 with a 3 and a 4. That's to have a minus 3 and a minus 4. So that works out. So this would be our factored form of our standard form. All right, let's do a couple with a number up front. One that we actually can pull out a greatest common factor. All right, I got to write these down because not every trinomial is factorable. And there's other ways to solve them, but today we're just working on trinomials that we can actually factor out. Because if you can't factor something, you got to use the quadratic formula. All right, so here we have another standard form. But now, instead of just having an x squared, we have a 2x squared in front. So we want to factor out any number divisible by, is there anything that we can divide into all 3 numbers? Yeah, we can divide a 2 into them. So we're going to factor out a 2 out of all of these. So by pulling out the greatest common factor, we're going to pull a 2 out, and then I'm going to rewrite my trinomial. So if I pull a 2 out of x squared, that just leaves me x squared. If I pull a 2 out of 32, 32 divided by 2 is 16. So it's going to be plus 16x. Like if I was to distribute it back in, 2 times 16 would be 32. 128, if I pull a 2 out of there, I'm going to get 64. All right, so we have the greatest common. We've already factored out the greatest common factor. Now it's time to see if we can factor our trinomial, our brand new trinomial. So we're going to leave the 2 up in front. Remember, the 2 is still part of the answer. We can't just get rid of it. And now here's where we set up our 2 parentheses. And since we have x squared, we're going to put an x in front of both. Now, once again, 2 numbers that multiply together to give me 64 and add together to give me 16. Well, in this case, I know that 8 times 8 is 64, and 8 plus 8 is 16. So I can do 2 plus 8s. So now we have the factored form. Here we go. So we got our standard form, and we have our factored form. And actually, we could convert this right into our vertex form. Because whenever we have the same binomials, we can just put one of them on there and square it. So this would actually be the vertex form. We'd have the 2 up in front, the x plus the 8 squared, and in the red would be our vertex form. So you have all 3 forms here. A little bonus math today. All right, let's do one more. One more. Y equals 3x squared minus 12x minus 36. All right, if you guys want to try it at home, maybe hit the pause button, bloop, and then try it on your own, and then come back and see if you get the correct answer. All right, so I have a 3 up front. I want to pull out my greatest common factor, which in this case would be a 3, because 3 goes into 12, it goes into 36, even though they're negatives. I can easily pull that out. We're starting out with easy factoring today. All right, so if I pull a 3 out of 3x squared, I just get 3 times x squared. If I pull that 3 out of negative 12, negative 12 divided by 3 is a negative 4 with the x. Don't forget the x. And then negative 36 divided by 3 is my negative 12. All right. Now we go down and we find the two binomials that we're going to attach to the 3. We draw in our parentheses, or a pairs of parentheses for a pair of binomials. We're going to find two numbers and multiply together to give me C, and add together to give me 4. Okay, so we got 12. Let's do that tree again. 1 and 12, that's not going to work. 2 and 6, well, that might work. And 3 and 4. 3 and 4 won't give us a 4 in any way, but look, 2 and 6 will, because the difference between 2 and 6 is a value of 4. So we're going to put our x's in. We forgot to do that. And we're going to use 2 and 6. Now, we want to get a negative 4. So what we need to do is we need to have both of these signs be the opposite. One has to be a negative, one has to be a positive to get a negative 12. So in order to get the negative 12, we want to figure out which one it's going to be. If we do a plus 2 and then take away 6, that will give us the negative 4. And if we multiply them together, we're also going to get a negative 12. Kind of like a little shortcut, or just to check and make sure you're doing it correctly. If this is a negative, if the second operation sign in your trinomial is a negative, so you know you're going to need two different signs down here. One's going to be a plus, one's going to be a negative. Whatever sign is in front of your b, that will go to the largest of the two numbers down below. So that's a negative. I know I need one of each down here. That's a negative right there, so that's going to go to the bigger of the two numbers. 6 is bigger than 2. We'll make 6 the negative and 2 the positive. And there you go. And if you want to double check your work, or you have multiple choice problems on your test, all you need to do is take your binomials, FOIL them. Once you FOIL them, you end up with your trinomial. And then factor in whatever number's out in front, and that'll lead you to your original problem or your original standard form. All right, if you guys have any questions, please ask me in class or leave a question or comment down below. Have a great day.